Good afternoon. And thanks very much for showing up after what must have been a very long day for you all. So I'm Cay Horstmann, probably best known for what you see here, that box set of core Java that has been in print for as long as Java existed. And so I keep updating it, and that's why I always need to know what is the latest thing in Java. And of course, you want to know what's the latest thing in Java. But what I want to do in this presentation is go a little bit beyond what are the latest features. I want to talk about, are those good features? Are those the features that we want? And if they aren't, how could we get the features that we want? So why do we care about evolution? We're, of course, all consumers of this wonderful product, but I want us to go a little bit beyond that and see what does it take to influence it. Bjarne Stroustrup, the inventor of another well-known programming language that should remain unnamed, it's C++, famously said, there are two kinds of programming languages, the ones people complain about and the ones that no one has heard of. So I will complain a lot about Java today, and but let's put in perspective. Java has been phenomenally successful in its original mission as a blue-collar language. So I'm reminded that not everyone is a native English speaker here. A blue-collar worker is the fellow here with a hard hat who may not be the most gifted programmer in the world, but so the language has to be easy enough that he can make progress with it. And by and large, it has succeeded in that. There are other languages that are fancier and more elegant, but Java's sweet spot is the kind of code that really every reasonably skilled programmer ought to be able to have a go at. So it's easy to learn. Java is meant to be unsurprising. The other reason that we use Java is because it has a vast standard library, and unlike other languages that should remain unnamed, such as Python, when you want to look for a particular feature, you don't have to make the choice between the 10 different implementations and figure which is the best one. Generally, what's in the standard library is what you would choose unless you had a very good reason not to. And most of the standard library in Java has traditionally been of really high quality. Java is, of course, incredibly backwards compatible, and that's something that shapes its evolution. And so how does this evolution process work? In the olden days, there was a process. It was well designed. It was well understood by everyone. There was this thing called the Java community process. There were Java specification requests. People from various companies or individuals came together, discussed how new features should work, developed them in these committees, and there was a process to get them approved or not, or to get them refined. And that process is no more. There still are a few JSRs out there. There is a JSR that every 6 months rubber stamps the latest version of Java, but it doesn't in any meaningful way shape how the language evolves. Nowadays, it's evolving in a different process. And so the pitch that I'm going to make to you in the end is you want to understand what that process is and see how you can shape it. So let's have here a very brief history of Java. Quite a few of these lines are so small that you can't read them, and that is by design. So what I wanted to put on here is how the versions of Java, how they include new features. And so the big lines are those where important new features came. You see in Java 5, we got a whole slew of new features, generics, the for each loop, and so on. And then nothing much happened until Java 8, when we got lambda expressions. Java 9, of course, modules. And everything else is kind of small stuff. There are a good number of big features on the horizon that will come. And so we want to understand how do they get slotted in. The other thing that we notice is the number of classes. I went back and counted them. Java 1.0 had 200 classes. I might have been off by one or two. And Java 8, that we all love, has almost 5,000. It went up at one point to 6,000. And now, for the first time in the history of mankind, it's no longer going up. So a whole bunch of classes were removed, as you know, in Java 11 and 12, no, 10 and 11. And that's probably just for the best. So things like JavaFX, which briefly was in the platform, is no longer in platform. Then some of the modules that had overlap with Java EE were removed. So the number of classes has gone down. Undoubtedly, it'll creep up from now on again. But then again, maybe other parts of the core will at some point be removed. We are aware of this picture, that the release cadence has changed. So now every 6 months, there is a new version of Java. And I, of course, look at these all the time because there's new stuff appearing, and it gives an easy way of finding out what's new and to actually play with it. And so it's shipped at some level of quality. I would imagine most of you couldn't care less that Java 14, is it 14, is coming out anytime soon, or that Java 13 has just come out, because those incremental releases contain a bunch of new features, but you're not going to put them into production. Now, this new release has given us kind of an interesting new way of getting new features. It used to be that you'd have to get some alpha releases or some beta releases. And so now Oracle is taking advantage of this new release cadence to give us a steady drip of new stuff, and we'll have a look at that. So just some terminology here. The way Oracle does this is they have overarching projects that have their own technical staff and that are tasks with certain things. There's a project called Amber, they all have silly code names, that deals with small incremental improvements to the Java language. We'll be talking about the switch statement, for example, and that was delivered by Project Amber. There's a project Valhalla that I will not talk much about today at all, because tomorrow Remy Frax will give a much more extensive talk about it that you should all go to. So those, its value types may not sound all that interesting, but there's a whole slew of new stuff coming up there that's important to know. There's a project Loom that I will talk about today. And there are many other projects. You may have heard about Graal, the ahead of time compilation. And there's a bunch of others. Like if you ask me what's in Project Sumatra, I'd have no idea. There are these Java enhancement proposals. So what used to be done in the JSRs is now done with these JEPs. They're much smaller. They're kind of more ideas. They're not necessarily fleshed out in the proposals, but they come at a steady clip. They're developed out of Oracle with some input by third parties. So that's a big difference, that you don't have the wide community involvement that you used to. And can you contribute? There are some people do. You have to sign an Oracle agreement, so it's not the same kind of thing as if you were to contribute, say, to an Eclipse project. So these are all tracked on the JDK bug system, and that's a good thing for us because there is, as I'll show you with some examples, you can pick up a lot about the progress by looking at bug reports, which is kind of interesting. And there are discussion groups, and that's another very useful thing. Those discussions are open to anyone to read. So there's a lot of very public discussion that gives you a good idea of what people were thinking. And sometimes you say, what were they thinking? And so you can go there. You can join as an observer. You can put in your own comments, and I'll talk about what happens to some of those comments. There's a couple of concepts. We'll look at an example of an incubator module. That's a module that has an API that's not final, that's out there for us to kick the tires, and that might get improved or changed later. There are preview features, and we'll see some examples of those. Those are language features. So incubator has something to do with an API. Preview features have something to do with the language. So let's look at a really simple example. Way back then, when you wanted to specify the car set of a file, you would do it with a string, in quotes, UTF-8 or something. And then there was always the problem, who knows how to spell UTF-8? Is it an underscore or a dash or whatever? So Java 7 had the standard car sets subclass that makes this job simple. And that way, you use standard car sets.utf-8, your IDE can autocomplete, and so that was clearly a good improvement. Java 7 made use of that in a single method. And someone said, hey, what about the rest of the API? That would also benefit. So Java 10 added support for that in scanner and print writer. For some reason, they forgot about file reader and file writer, and they added that in Java 11. So now we have the support, and that's great. So that's a poster child of something that works really well. So you can look for other enhancements like that by looking for the for CSR in the bug database, and you find a few things here and there. And you could, of course, try to lobby for having your own favorite small enhancements put in just that way. So that's a well-known process. Let's look at something that's a little bit of a bigger scale, the HTTP client API. In 2012, it was proposed to add a new HTTP client API that would replace the not very nice HTTP URL connection API that has tons of bugs. And so they said that's a dead end. In 2014, they said, well, this would be a great opportunity to add HTTP2 and WebSocket. In 2015, the first prototype of this materialized. It didn't do any HTTP2, though. In 2016, there was some minor API revisions. It's not clear where they came from. So I don't even want to go through the API. It's here in tiny fonts in case you want to look this up later. It's a fluent API. It's a perfectly reasonable API. Looks modern and everything. And it is now. Well, let's get to that later. The one interesting thing about it that is that you can do asynchronous processing with it. So it's you can say you want to make an HTTP request, and then you use a completable future to consume that. Completable futures are a fairly new feature. So here you have a newer API that integrates with those other new features of the Java platform in perhaps a better way than some of the third-party APIs would. So 2017, we got this thing in JDK 9 as a incubator module. So it was in a special module, and when you used it, you had to turn on a certain flag. So you could try it out. There was then a JEP to say, let's make this standard. And in 2018, it was made standard with very, very minor changes to the API that you can look them up, but they were really trivial changes. And so what I want to look at is, okay, fine. So you had this thing. It evolved over many years. It was put into preview. Or into incubator. It was then made final. So now we have it. Well, it should be perfect now, right? It's been, what, 6 years or something? But when you look at it, from a user perspective, it leaves things to be desired. So it has these body publishers, but if you want to still do an old-fashioned form post, no support for that. You still have to make your own. It doesn't take many lines of code to do it, but it's a hassle. You want to do file uploads? Forget about it. There's no support for file upload. So libraries that preceded it, they would have this just for normal programmer convenience. But here it is 2019, and you still have to worry about my multipart, which is, it is what it is. Okay. There's no JSON support because JSON is not part of the core Java platform. And that's the way it is. So one could, of course, hook it in, but it's not done. There's no automatic handling for compression. There is no way of dealing with controlling high-volume concurrent requests. So HTTP2 might just say, go away, there are too many requests, only give me so many, and there's no way for you to control that at all. There's a bug report out there. There is a thing that surprised me and that Heinz Kabutz recently put everyone's attention to, that the way that the executors work for asynchronous requests is weird, that there is a way of specifying an executor. Let me just highlight this line so you can see there is a way of doing that. And so you specify some thread pool, and you would say, well, that probably is the thread pool where when the follow-on work gets done, that's going to happen in the thread pool. It better be that, because otherwise the follow-on work would happen in the fork join pool, in the common fork join pool, and you probably don't really want to do arbitrary work in the common fork join pool. That turns out to be false. So the implementation uses this thread pool for internal stuff that no one understands, other than the implementer. So it's not clear why we would want to set another thread pool, but there it is in the API. And it was, in fact, noted in some bug report that the docs are wrong, and now it's being corrected. So the takeaway from this is it's a fine API, but still, after many years, it's not a great API. It leaves a lot to be desired. And so why is that? So didn't people have a chance to look at it for a long time? But the problem is, of course, for many years, it was kind of being worked at, and the interest level of anyone who is not an expert in this is low. There were a few experts who put in constructive comments, and they weren't necessarily heard at the right time. So the thing comes out, and by the time that it's there in preview, it's pretty late to make real API changes, and the API changes, like I said, were very minor. Now it's a part of the core library, and so we are stuck with it. The time between preview and putting it into the core library was probably too short. So there you have an example of something we say, this was actually pretty good. It's a vast improvement over what was there before, but it could be better. So let's look at another example of that kind of evolution. Raw string literals. If you've gone to an earlier talk, you probably heard about text blocks, and we'll come to that. These are the predecessors of that. So in January 2018, it was proposed to have a new form of strings. And so the idea is if you have a foreign string, like something that comes out of SQL or HTML or something, and you have a page of that thing. And right now, if you want to make it into a Java string, you know what you have to do. You have to put quotes around it. You have to put pluses at the or new lines or something, and it's a pain, or both, right? So there's right now no easy way of dropping in a bunch of foreign code. Of course, your IDE could do it for you, but then the result gets to be a somewhat unreadable mess. So the goal was to have what you have in other languages, these kind of raw strings. They should be multi-line so that you didn't have to put them as single-line strings with a bunch of pluses. A bunch of non-goals is they didn't care about string interpolation, and they didn't care about things like post-processing that you might have, like with formatters or something, like in message format. And they had a simple and ingenious idea. They said, well, the problem with any kind of raw string is that you have a delimiter, and then you have the raw string content. And how do you know that the raw string doesn't contain the delimiter? So they said, well, this is what we're going to do. So we're going to say that as the delimiter, they chose the backtick, because it was not used for anything else. And they said, well, make it so that whatever it is that you want to inject, let's say that it is markdown, and there's already 3 backticks in a row in the markdown segment, then you use 4 as the delimiter. You use at least 1 more than the largest sequence that you find in the stuff. Then you want to paste in. You can put 20, it doesn't matter. 20 backticks, your stuff, and another 20, who cares, right? Another 20 backticks. It's easy, it's ingenious, everyone can understand it very quickly. Yeah, you're laughing, and so you got it, okay? There was a teensy problem, and that is that the raw string could not start with a backtick, right? Because then you couldn't tell whether this was part of the delimiter or part of the raw string. So now I asked about that in the mailing list and said, well, why don't we just make it so that you do your 20 backticks or 4 backticks or whatever, and then you make an enter, and then you start the raw string. Because after all, if it has many lines, that enter probably is actually better to have it. And I was actually frustrated that I got 0 answer. I asked a couple of times more, and nothing came out of it, but hold that thought. And so that was all fine, and now something very strange happened. Now here we have a good example of this feature, my name in a box, And so notice I wrote it the way that I would normally write it, with a backtick here, my foreign stuff in here, and another backtick, and it's fine. But it doesn't blend in my IDE. Wouldn't it look so much nicer if it looked like this? So that was proposed in the mailing list, and I looked at it and said, whoa, that's going to be problematic. What about tabs? All right? It's not that we don't have any experience in other languages where people are forever wailing and rending their garments about tabs and spaces. If you ask Guido von Rossum if he again would allow people to use tabs and spaces in Python, he would tell you, hell no. Right? This is an unproductive discussion. And so I thought that what really would come out of that mention about tabs is like, yeah, that was a dumb idea. Let's move on. But no. So it was taken up, and so it was seriously proposed to figure out what is the common prefix. And so the first solution is to say, well, it has to be the exact identical sequence of invisible spaces or invisible tabs. And then it'll be stripped, and otherwise it won't be. Later they said, well, there's good reasons for that. Later they say, well, that's not going to work. It has to be a sequence of any kind of white space, so you could actually now put vertical tabs, but they all count the same. So that's kind of problematic. And so this went back and forth. There were hundreds of messages. And so when I saw this beauty here, I thought this was surely going to kill the discussion. So when someone said, yeah, so in his email, he said, here's another example, but you have to look at the stray case, and I thought I caught them all, but the mailer messed up my spaces. You would think that if someone sends an email that says the mailer messed up my spaces, that they would think twice about baking in a feature into a programming language that messes with prefixes of spaces and tabs. But no. So the discussion was there. We had it implemented, and a few weeks later, the whole thing was withdrawn. And I thought, oh, great. Someone saw the madness in this and said, this needs some more thought. So why was it withdrawn? Someone said, well, the backtick could be confused, two backticks could be confused with an empty string. Sure. That, like we already observed, you can't have a raw string that starts with a backtick. And that some people said, well, the backtick's kind of hard to see. I guess it is. And someone said, well, any number of quotes might be confusing to IDEs. I don't know, but maybe some IDEs would find it confusing. So they came up with a whole new feature, and you probably heard about that today, text blocks. So text blocks still do multi-line, but they're not raw. They're more like medium rare. So with a text block, you use triple quotes, like in many other programming languages. But of course, then you face the problem, what if the text that you're putting in there also has quotation marks? Well, if there's only one or two, it's okay. But if it has three, then you need to escape at least one of them with a backslash, like you see here. So it's not as convenient for pasting in arbitrary stuff. You have to scan the arbitrary stuff for three or more quotes. No, not so many examples have three or more quotes, so you might not be too worried about that. What about backslashes? Now, of course, you have to escape backslashes. Lots of stuff that you might want to paste in from elsewhere is going to have backslashes. So the raw thing is out of the window. Notice, by the way, that now the new line after the initial triple double quotes there is required, which if they would just extend it to having n quotes, they would have a perfectly good way of doing raw strings. So like I say, backslashes. And the useless feature to strip spaces has not just been preserved, but expanded. Now it strips trailing spaces. So if you have some text that is preceded by some white space, and there might be some white space after it, then it gets munged in a way that's hard to predict. So if you want to have more control over that, where you might actually want to retain some of those trailing spaces, then you can insert other escape sequences to do that. So this is actually shipping with JDK 13, mercifully still as a preview feature, so if enough people hate it, it might again go away. But it's kind of pathetic. Yeah, it gives us multi-line. It doesn't give us raw strings, and doesn't give us any of the things that we have in other programming languages, interpolation or post-processing. So I would say this was not a success of the process. There is any number of better solutions out there, and somehow the process has failed to find them. As another example, and I will briefly prefix this with what the goal is. One of the things that Java wants to have, and for very good reasons, is much better pattern matching. So I'll give like a lightning introduction what you can do in other languages like Scala, where you can match on types and say, if I have something, I want to match on whether it's an integer or a string or something else. You can't do that today in Java except with a sequence of instance offs, which is not so pretty. You would like to be able to extract things from a match. So if you know that something is an array, you might want to extract the first element, the first two elements, and so on. That's something that you can, of course, do in Java, but there's no pretty syntax for it. And you might want to have that extraction feature work with variable declarations. This works in JavaScript just fine, for example. So why not in Java? It works in Scala, of course, which is where I have these slides from. So this is a long-term goal in Java that we would like to have a better facility for pattern matching, and that's a noble goal. So there is a JEP that is something that's going to be implemented soon, where we can say the following. Here we can say ch is opt instance of string, and notice the s here. So now s is now going to be the same thing as opt, but it's typed as a string. And so that way you don't have to do the sequence that you have to do today, where you do an instance of test followed by a cast to the exact same type. So that's obviously useful, and they've thought this through very nicely. They said if this cast succeeds, then s is in scope, and then we can use it as a string. Notice we're calling isEmpty on here, which is a method that only works for strings. So that is coming, and that is great. There are some musings in the mailing list and in publications by Brian Goetz and others about how this could possibly be extended. So where we could say in a switch statement, we could say case string s, or we could say case point, and then pick up the coordinates of the point in this way. Would obviously also be useful. And now, I, for one, am very much looking forward to having this thing in the language. I've used it in Scala, I've used it in JavaScript. So it would be nice to have these kinds of destructuring capabilities in Java. And so the sooner they can give them to me, the better it is for all. I'm concerned. What are they giving us? You know what they're giving us because you've probably gone to a talk or two where they talked about switch expressions. So switch expressions are a good starting point for that. So here we have how this is looking like. So you use the switch keyword, and you say, well, if you have a case Monday, Friday, Sunday, then you return 6. That's the number of characters in those strings. For Tuesday, you return 7, and so on. And the syntax is straightforward enough. We're familiar with the switch. We have cases. Note here we have this arrow, and what comes out of this is a value and not a statement. So in each of the different branches, a value pops out, and one of those values is going to be the value of the expression, and that gets now put to the left-hand side of the equal sign. Easy enough. So this is an expression. It's not a statement, and many other languages have that, so it's great. Now, in fact, it is kind of like a multi-way form of the conditional operator. Like question mark colon is also an expression. It's like an if statement, except it's an expression. Hold that thought. So notice there's no fall through. A switch statement has a fall through because it does. It must be exhaustive. That's a good thing. So there is no way of writing one that fails to match. So the compiler will check that we covered all of the enum cases in this case. But you can have a default in case you do that on integers or something. So these changes will simplify everyday coding and prepare for the way for the use of pattern matching. That's the pitch in the JEP. And so there it was in JDK 12. And it's now in JDK 13 with a minor change. And that sounds great. Yeah, it may happen to be in JDK 14 as a standard feature, which means it will forever be a part of Java. So there's only one teensy problem. So here's the problem that they tried to solve, and in that they created a much bigger one. So let's say that here you want to, in the branch for Tuesday, you need to log the fact that it was Tuesday, and then you return 7, the number of characters in Tuesday. Then that's two things, and it's a statement and an expression. And so in Java, there is no block expression, so you can't just do what I wrote here. You could do that in Scala. So lambdas, by the way, suffered from the exact same problem. That if you have a function here a lambda that returns x times x, but now you want a logging message here, you also have to switch strategies, right? You have to put the braces, and then you have to use the return. Well, there's precedent. Right? We could do the same thing here. Yeah. A return inside a switch. So people didn't like that. So in JDK 12, they said, well, what is kind of the moral equivalent of a return? It's a break, right? You break out of a switch, and now we're going to be breaking with a value. So we're going to be breaking out with the value 7. And yeah, it's internally consistent for those who can hold their lunch after they see that. But it has a lot of issues. And, sorry. So here's one of them. Break is, of course, used elsewhere. And so here, if I have a for loop and I use a break here, well, then that would interfere with the break. And yeah, you can learn what the rules are. Here is my favorite issue with it. What about a labeled break? That other silly feature that very few people use. So it interacted poorly with those. So in JDK 13, they decided to change the name. It's now called yield. So what's wrong with that? I'm sure it's great fodder for puzzlers. I'm disappointed about break being gone because I had some great puzzlers with break. But there you go. So, well, what about the old switch, the toxic one from the days of C? So they said, wow, we're going to gussy this one up and give it kind of the same possible treatment. So now with the old switch, you can also use arrows, and then you don't use breaks. What if the new switch would like to have fall through? Oh, be my guest. Here you have a new switch with fall through. Now remember, this is all done for us to have pattern matching. Pattern matching is a glorious and wonderful thing. An expression switch with fall through is not. So evolution is here not a one-way street. So this was all sold as saying, well, it'll make the language easier to learn. I happen to know a couple of things on how people learn languages, and this is not how they learn it. So this matrix was put up that said, well, there's two axes. There is it an expression or is it a statement? And does it have no fall through? Does it have fall through? So in order to complete this matrix, we now have in the expression and no fall through corner a beautiful statement that we all would like to use. In the corner over here, the old switch statement that we're stuck with, whether we like it or not. And two others that will baffle countless generations of students. But it's good, because I sell these books, and the more confused people are, the more books I sell. So where did this come from? So, so the explanation was that it would be saner to have these two different features, so that switch expressions and switch statements could be on the axis on the one side, and then the fall through and the non-fall through on the other side. And that's interesting, But let me show you another matrix. So here on the horizontal axis, I have statement and expression. And on the vertical axis, I have two-way branch and multi-way branch. Now, on the statement side, the two-way branch is if-else. The multi-way branch is switch. So on the expression side, the two-way branch is question mark colon. And the multi-way branch is switch. Why switch? So the premise that the switch expression must be a switch expression is flawed. It could have gone other ways. Someone could have said, well, maybe we should have a multi-way expression, and I'm just to show that it can be done, call it here question mark. Yeah, multiple. And there's any number of syntaxes that someone could have come up with. But the whole premise is not necessarily true. And anyway, this has nothing to do with pattern matching, right? So this is another case where I would argue that the design process, it's out in the open, anyone can join and be ignored, is maybe not optimal. So that's the kind of the highlight, the backstory where I want you to think about some of the newer features that come along and say, how can one make sure that there is feedback, that we all give better feedback, maybe slow down this process, or at least give our opinion. Mine is only an opinion. I fully realize that I may not be right, although I don't think so. So let me talk about a couple of the newer things where I think things are actually working much better. So that should give us all some hope. Where there was a similar discussion and which I think went in more fruitful directions. So one of the features that fits on one slide that's going to be coming soon, I am told that it might even come in JDK 14, is records. So a record it's immutable data. It's like public data. So here, the poster child is the point, right? A point has an x and a y coordinate, and it'll always have just an x and a y coordinate. Can have methods, but the data representation never changes, and we don't really gain anything from encapsulating it with private and public and that kind of stuff. So when you write this down, then you will automatically get a Java class out of it with private fields and accessors that read like x and y, like the field, like the names of the things that you put up here. You get equals, hashcode, toString, that kind of stuff. So you get an immutable class, and you just now have a shorter way of describing the class. So that, of course, an IDE could have done that before, and they have ways of doing this, but you get it automatically. You can't add any other instance fields. At some point, there will be some feed-in into pattern matching that you can describe how to extract features from this. Or it'll do it automatically, or there'll be some syntax for it. The final, they're not abstract. There's a super type record. They're serializable. So in essence, they're tuples with names. And that's very much in the tradition of Java, right? In Java, we tend to give names to things. Whereas in languages like Scala, you might just say, well, I'll just give out a pair of an int and an int, and that's my point. But in Java, we like to say, well, it has a use. It's a point. It has a semantic meaning. So what's nice about this feature is that unlike the previous feature with the switch, where there was really very little data to argue one way or another whether people were hungering for switch expressions with fall through, here there is some data. So someone at Google looked at, so they have an internal library, and they kind of have a way of making these value classes, or records, I should really say, because value class is something different, as you'll see tomorrow. They had a way of making these records. They had a tool for it. And they said, so they measured, how did people use that tool? And so they said that it was about, from what they were guessing, from the numbers, that it would be about as popular as using enum. So they looked at a substantial amount of code where people used these automatically generated records. And then, yeah, people do use them, and it doesn't solve world hunger, but it's like enums. They're a nice feature. And so that's good data. I mean, it's really good when you have this kind of data. And so when that came out, I think it kind of gave everyone a warm and fuzzy feeling. And the other thing is that feature mapped exactly to this design. Immutable with auto-generated getters. And so everything else was done exactly the same way. So it really validated this approach. So that's good. And so, of course, as with everything, then someone comes in and says, well, I have this other problem that I also want this feature to solve. That would have complicated the design. And I think there was correctly a bunch of pushback to say, this is a feature that does one thing, it does it well, but it's not designed to solve every last Java boilerplate problem. So the other thing that people will often want is with properties and setters and things. And so it was just said, that's not what this feature is about. It's a simple, straightforward feature that will soon see the light of day. So here you see some evolutionary thing where there was discussion, but there wasn't it wasn't like particularly controversial or anything. It'll make it into the language. It's off the quality of enums, about nice, uncontroversial feature. So, so let me talk about another thing that's coming up that is interesting, and that I really want everyone to encourage to just pay attention to it. And that's this project Loom. So some history. In 1995, when Java first came out, you're all too young to remember this, but I do remember this. Everyone was excited that here you had an actual programming language that had support for threads, that it had locks. In 1997, when the Java web server, the thing that now called Tomcat, it was an exciting thing that each web request was run in a new thread. In 1997, that was big news because most web servers ran each request in a separate process. So it really was amazing then. Thousands of these concurrent threads. Nowadays, of course, that's not so exciting. We know threads are expensive. And so then what do you do, right? So you have a thread and it blocks. So we all do asynchronous programming these days. So we're very aware that anything that blocks, instead of just waiting for it to happen, we just say what has to happen afterwards. And so then you get into callback hell, futures hell, or things like async await, where you have the blue pill versus the red pill. That half of your functions are tainted by being async. So these are all not super wonderful programming models. But they're things that we do deal with all the time. So Loom wants to go back to the basics. The Erlang people have laughed at this forever and said, why? We can run millions of these lightweight threads. And the Go people, the same thing. So the Loom people say, what if blocking was free? What if blocking wasn't expensive? You just block. And so you'd have millions of these concurrent fibers. And these fibers are executed by threads. When one of them blocks, it gets parked, and the thread does something else. This is not new stuff. And so what do they have to do? They have to just make this work. And so they're working on that. And it is I'll show you a little bit of code with that and tell you how to kick the tires. And of course, as with everything else, you look at the documentation, and there's maybe a bit of over-promising, right? That says, oh, this is done to make concurrency easy again. And so we need to take that a little bit with perspective. There's more than one reason to do concurrency. One trivial reason, or one common reason anyway, is in user interfaces, that the UI components are not thread safe because it's too hard to make them. It's been tried and not. And so you serialize them in a UI thread because that's a fairly easy thing to do. And you can't bring down the UI thread, so you need some kind of asynchronous programming. Fibers won't help anything at all for that. So for that situation, keep on using your swing worker or your async task or whatever. Remember the last time that we had a solution that's supposed to make concurrency easy again? Parallel streams. That's how it was sold then. And parallel streams, work great when you have workloads that don't block and work on a splittable data structure. So if you work on an array that can be split up and you have tons of work that needs to barrel through on each of the segments, parallel streams work great. So with fibers, it'll actually be okay to block, which is kind of interesting, because right now the people fall into this trap that they block in, they use parallel streams, they block in the operation, and of course they can quickly starve the fork join pool that way. So that would be very bad. With fibers, you could do that, but really only if you work on splittable data structures. So there will be lots of use cases that parallel streams, even with fibers, are not amenable to. So generally, if you have computationally intensive tasks, fibers are not for you. You do not want to have 1 million fibers that run computationally intensive tasks for obvious reasons that your processor would not do well with that. So the sweet spot for fibers, and it is a sweet spot, is if you have many more tasks than you have threads, like that web server with lots of incoming requests. So can you get it? You can actually download every once in a while a pre-built version for it. I don't recommend it because they don't come out very often yet, at any rate. But it is pretty trivial to build. So if you can build it on any Linux system, and I'm sure you can build on a Mac exactly the same way. It builds in 10 minutes, and there you have the daily release of the thing. You can run 1 million fibers. So here I'm running 1 million fibers, and just like that. And so I can make them do something trivial, and it really does work. So here I'm just sleeping, and I can sleep in 1 million fibers. I tried to do that with threads, and after about 10,000, and ran out of memory on my machine. So obviously, that's, if you just want to sleep, you can do that today. Works great. And there are other things that work today. I'll show an example in a minute. Now, so that's one thing they wanted to do, and then there's now a bit of mission creep in a good way, that there's this general movement for what's called structured concurrency afoot. This guy, Nathaniel Smith, said if you have not read that blog, then you should read it. It's a great read. So Smith says the kind of way that we currently deal with coroutines is like Goto in the 1960s. That you start a Go routine in Go, or you start a new thread in Java, and what that really means is you kind of go into outer space and you no longer know what your program does. It'll do something, and it's very hard to reason about it. So in the 60s, people said you have the same problem with Goto, with the traditional Goto statement, and so what you need is better structuring mechanisms. You have branches and loops and function calls, and they tell you exactly how to reason about a program. When you're in a function, that function is going to come to an end. If you have a loop, that loop's going to come to an end. Of course, it helps if you don't have silly structures like break to break out in the middle. But so that's the structured programming idea at this point. We've all bought into that. And so with concurrency, the basic idea is it should kind of be the same. You ought to be able to reason about it in some way. You ought to say, well, I'm doing these three things in parallel, and then I come back together, and then all of those tasks are done. And so there ought to be some way of wrangling our concurrent code into this more structured form. One reason, for example, is that way we can deal with cancellation. We say, we'll just cancel this entire thing. We can deal with resource deallocation at a common point, which currently, when you have your typical async spaghetti, is a hard thing to do. So that's now something that they want to solve. So the way it's going to work is like this. We're going to make what's called a scope. So a scope is something in which you can schedule a bunch of fibers. They're all in the scope. And so here we're scheduling the fibers. And at the end, I'm going to close the scope. Here I'm doing it explicitly. You can also use a try with resources block. And when you close the scope, then all of the fibers have to finish. This is kind of this synchronizing point. Well, what if some of them just keep on running? So then you can say that as a part of setting up your scope, you give a timeout, or the way they prefer you to do it, to give a deadline. So a deadline says, finish 30 seconds from now, because as they correctly say, deadlines compose better. But you can do either. So the idea is that the scope gives you a way of controlling these fibers in a meaningful way. Just like you have executors now, and you can kind of do the same thing. But that's the spirit. What about cancellation? That's always been a trouble in Java. With fibers, you can call cancel on a fiber to set a cancel status. That's kind of like an interrupt status. In the interest of time, I don't want to go too much into detail. But if the fiber was parked, then it unparks it, and it makes it wind itself down. It is cooperative, just like with interruption today. And there's minor details that they're thinking through. It's a little bit less crazy than interruption, which has a very ancient and weird API. You can, when the scope times out, the fibers get canceled automatically. It makes it for much easier programming. And like I said, cancel is a little bit saner. You can't turn it off. And, you can customize it. And again, in the interest of time, I don't want to go into the API. I'll give just one example that when you get the slides, you can look at the link. So Heinz Kabutz had this problem that he showed off at JCrete, where he was using the typical HTTP client asynchronous programming, and so he loaded thousands of these Dilbert images, and it didn't work. So for each image, he had to load a website, he had to parse it for the URL, then he loaded the URL, and then he tried that, and it was a mess of computable future. This is this much simplified version. It looked 3 times as bad. And so his puzzle was, why doesn't it work? And we had no idea why it didn't work, but we did figure it out in the end. But if you write it with fibers, the code gets much cleaner because you write the way you think about it. And yeah, you load this page, and then it blocks. But so what? Blocking is cheap, right? It parks the fiber, and something else will happen. And so I tried this code. The first time I tried it, it crashed and burned. But a couple of weeks later, it worked like a charm. So the library is now at a stage that they have gone to good parts of the Java API and made stuff like this work. So there's a bunch of discussion about the API. Is a fiber a kind of thread? Maybe that's not so good, because Java-lang thread has a bunch of craft. I don't even have to go through the craft, you know what it is. And so they're investigating, should fiber extend thread? Should there be a common, like what they call a strand, so that both fiber and thread extend strand? Should they not be related at all? In every permutation, they've actually been trying out and seeing where that gets. It's quite interesting to follow. So that we don't yet have a consensus about this at all. So there's a bunch of pain points that they're running with the various approaches. There's footprints. If fiber is a thread, it takes away a lot of the footprint from a thread, like thread locals that we don't really want. Compatibility, and that I think is something that we all should think about. To what degree do we want fibers and threads to be the same thing? Given that the thread API is not necessarily something that's withstood the test of time, maybe fibers shouldn't be threads. One reason that they're now going back to that fibers are threads is that it makes their serviceability work a lot easier. And that may or may not be a good motivation. So then they're thinking about things like thread.current thread. You do not want to expose the thread that a fiber runs on, because what if the fiber then starts interrupting it and then messes up all the other 1,000 fibers that run on it? So they, of course, are thinking about that. Do you want fiber locals? Probably not. But what kind of locals might you want? So right now they're talking about maybe scope locals, and it's something that's under active discussion. So I'm not going to go into that. So this is something that is being very actively worked on. So a bunch of stuff has been made fiber friendly. Thread.sleep, of course. The locks. NIO and sockets, that's what made me port that program, Heinz's program, with the image loader. TLS. And so actually, and that's kind of an interesting sideshow here, is they're making these things fiber friendly so that fibers can be parked when any of those things block. And that makes them do a whole bunch of engineering rework that they're quietly putting into JDK 11, 12, and 13. And none of us notices it because of modules, actually. You know, we love to hate modules, but that is a good side effect of modules. And so it's also a good side effect of having this steady flow of small releases, that these re-implementations now get quietly tested in the wild. So interestingly enough, you can't yet block on intrinsic monitors. And so there's a bunch of other work going on. And you know, when you run it, you will find that every once in a while it just blows up in your face. So it's still young years. Performance, lots of work ahead. So this will eventually come. And you know, I think it'll be a beneficial addition to the repertoire. And it's kind of up to us to shape it. So if you're into this kind of stuff, you know, just run it, put some workloads on it, and help them out, and give some feedback on how the API should look like. And so that's kind of my general pitch, that Java is so far from done. You know, we kind of think that it's been there for so many years and it's got to be done, but it really isn't. And so there are major structural changes that are being worked on by very smart people. And there are also features that get a lot of attention that they probably shouldn't. And it's not clear that the interest of application programmers, of you and me, are necessarily represented in this process. And it's partially kind of our fault because we're not really paying as much attention as we should. And so they need us. So go and read those JEPs. And if you don't want to read them, have someone in your company who reads those JEPs and who gives occasional presentations about how this stuff moves along. There's a bunch of project pages, white papers, and everything. They're fairly easy to read. You don't have to read them all, right? But I do because I need to update these books. But you could just take on one of them that interests you. Try those early builds, and don't wait until something is actually in JDK 15 or something, because by that time, it's probably too late. And if more of us, I think, gave active feedback on the discussion group, good and bad, I think that would be good. You don't have to go to the discussion group. You can write some scathing blogs. I've done that, and with some effect. So just be involved in these early stages. And the other thing is, if there's anything that you can do about data, data is gold. Like the fellow from Google who had the data about what's now record. So if you have a large body of code, and you could just try out whether the text blocks are actually helpful or not, or whether you look at how you use switch, or any of those kinds of data, that would be a great thing to have. So that's kind of my pitch here, to say there's a lot of stuff going on in Java, and they need you. Thank you.